Okay, good morning. I'm planning to do Leetcode contest 287 from last Saturday. All right, so here we go. All right, open these guys up. Doop, 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 doop. Okay, minimum number of operations per time. Okay, hours and minutes. Increment the current time by 1, 5, 15, or 60 minutes. You can perform an operation in number of times. Return the number of operations to convert current to correct. So we want to greedily consume hours and then quarters, right? So those are the minimum. Okay, so let's just do S and T. Let's see, start this guy off, do a game plan. Okay, let's see, 8:03 a.m. Game plan will be to greedily consume the maximum amount of time. And we have to count up, or can we go count down? Earliest 24-hour time is latest that. Okay, we want to go this to that. So this is our target, right? Okay, that makes sense. Consume the maximum amount of time to mutate the input string S to the target string T. Okay, so we basically want to convert the values and then check how far up we have to go, like how many minutes there are from current to correct. Right, so determine the delta in minutes. Then take the largest chunk, right? 60, 45, 30, 15, 5, 1 at a time to return the count, right? Okay. Count is 0, return the count in the end, and then we need to subtract that from this. And then the only weird part is if we have to borrow hours, and then there's maybe the weird wraparound use case we might want to consider as well. So I think it makes sense to use a common offset, right? Maybe we can do a common offset, right? Remember to keep it super simple, right? KISS, keep it super simple. So what if we count up from S and also count up from T to the max, this guy? Then take the delta of that. I mean, I guess the end goal is to simplify the logic of counting up from S to T. I wonder if it's symmetric though, if we have to wrap around, right? So question, the hard part, right, seems to be the wraparound case maybe. When S is larger than T. So if S is, let's say S is 2359. S is this one, and then T is 0, 0, 0, 0. It costs 1 minute. Maybe it's not hard then. I mean, you count up to it in modulus, I suppose. And maybe I'm getting stuck in analysis paralysis. So let's just start writing something, right? So 8:03 to 8:06, that's kind of our game plan. 6 a.m. 3 minutes, game plan. Okay, 807 or the implementation. Let's just start writing some code so we don't get stuck in the analysis paralysis state. So let's just simply write it as counting up in minutes and then counting up in hours. Right, each hour is 60 minutes, but we also have to have even this guy to that guy. So this example, let's just code for these first. So the simple case first, how about? So let's see, hours and minutes. Let's do 0 and 0. Is H. So as you want to parse it into an integer. I wonder if this works. Println 01.2int. I don't think this works, right? It's expecting like a pair. Zero 1.2int. Oh, it does work. Okay. Function f will take a string and it'll return a pair of integers. All right, so this would be our helper function. Hours equals s dot slice 0 to 012 non-inclusive. Let's just do 0 to 1 inclusive. Dot 2int var m equals s dot slice 0, 1, 2, 3 to 4 inclusive. Return pair hours minutes. All right, and let's do this. Our h1 m1 equals the function of s. Our h2 m2 equals the function on t. And then we want to count up from s to t. So our h3 m3 equals here. That's the absolute value. Actually, now let's just do this. Let's do h2 minus h1, and then m2 minus m1. So it'll be negative. We have to wrap it around. So I have to end that case next. H3 at 60 seconds for each hour. 60 seconds. And then minutes we can take into chunks of 45, 30, and 15, while M3 exceeds 0 if M3 exceeds or equals 45. We can take that chunk. Increment the count each time this occurs. M3 minus equals 45, else if 30 is less than equal to M3, M3 minus equals 30, else if 15 minus equals 15, 5 less than equal M3, M3 minus equals 5. Also if 1 is less than equal to M3, M3 we can just do these in ones, whatever. Okay, so that should pass the simple use cases where there's no wraparound, right? So that is 3, the other one should be 1. Now we have to do the wraparound case though. Okay, so 807 to 812 implementation for naive use cases, and then we have to do the implementation for the wraparound use cases. All right, so 813. Let's get to this and wrap this up. Okay, so let's say if we want to do this backwards. It's S and T. It's this guy, so we want to do it backwards this way. This guy's going to be T and this guy will be S. Right. Okay, so in this case, we have to count up from T. Hour 1 is equal to 2. That needs to go up to 23 plus H2. Wait. Okay, so hold on. H1 is equal to 4. Hold on, sorry. H1 equals 4. Right. M1 equals 35. Happened to my music. Oop, hold on. Pandora going. Okay, here we go. Okay. H2 is 2, M2 is 30. So we can go 23 minus 4 equals 19. All right, so we add 19 and then add 2, right? 19 plus 2 equals 21. Does that sound right? It's 21 hours. See, it's 24 to go exactly 1 hour to another, so that's minus 2. So maybe actually it's 22. Right, I mean, 24 minus 4 is 20, and this would be 22, right? So 24 goes from 4 to 4, minus 2 is 4 to 2. I think that makes sense. Actually, we want to take into account the minute difference first. Then if we need to borrow, we reduce the hour by 1. Right, so if you have 0, 0, 0, 1, and we have to count up to 0, 0, 0, 0, let's go all the way up around, right? So it's 24 hours plus 1 minute. Wait. Plus 23 hours and 59 minutes, isn't it? 23 hours, 59 minutes. All right, so count up 59 first. So subtract that from 60. Okay, so if the difference is negative, then subtract it from the largest quantity. As for minutes, 60, for hours, 24. Okay, so if M3 is less than 0, M3 equals 60 minus M3. And then the hours, we basically borrow an hour, right? So the minutes of the first one is greater than that one. So you borrow an hour from this guy, right? Does that sound right? M2 minus that is -1, so that's 59. And then we would borrow from H2 in this case, right? So that'd go to -1, right? So it's subtracted by 1, right? H3 minus, right? So, oh, yeah, right. So we borrow an hour. If H3 is less than 0, then we'll do H3 equals 24 minus H3 plus, right? Plus, because it's negative. Okay, so that way, but then let's do it the opposite way. All right, so the opposite way should be counting up. It's not a complete 22, so it's 21 and then 5, right? Or wait, no, 21 and then 55, right? 21, 55. Current should be less than, oh, it's less than or equal to? No way. Even say, oh, current is less than correct. Oh, okay. I don't need to keep in track of that use case then, where we even have to consider it, right? So it's fine. Okie dokie. Well, we'll revert back to this guy, and it's fine. You just count up from one to the other. So it's really kind of silly how much I've overcomplicated this one, right? That should be okay. Oh no. Output's 30, but we expect 32. Really? Okay, so wasted some time on invalid use case where there is wrap around time. Oops. And anyhow, this is an incorrect solution. All right, all right, let's work through this guy and see what's going on. 30, we expected 32. So it's from 0 to 23. It cost us 23 hours, right? So count equals 23. And then we should be able to take 45, 5. Wait a sec, hold on. You can increase the current time by 1, any number of times. that's 50, 55. How does this add up to 32? What the hell? 23 individual hours. Right, 45 minutes. Right, so it's 59 minus 45 equals 14. 14 minus 5, it's 9. 9 minus 5 equals 4, and there's 4 left. Right, so this should be plus 1, plus 1, plus 1, and then plus 4. 23, 24, 25, 26, so it's 30. Okay, so I come up with 30 per this calculation. So what the hell is going on? All right. One, 5, 15, or 60 minutes. Minimum number of operations convert current to correct. So why do I need 2 more operations? Why is this 32, right? Why is this 32? It seems that 30 works okay. Right, what the hell? This is stupid. It locks algorithmic complexity, and it's just kind of a silly question, right? And what the hell is this? In one operation, you increase the time current by 1, 5, 15, or 60 minutes, and you can perform this operation any number of times. Minimal operations current to correct. How is this possible that it's 32? I mean, assuming 60 turns into 1 hour, right? Right, 0 to 59, 0 to 23. Oh, there's not a 45 or a 30. Damn it. Okay. Okay, yeah, make sure you answer the right question. Actually read the problem statement, right? Okay, well, that makes sense. Holy cow. Okay. Note to self, read problem statement. So we solve the actual correct problem. 32 is correct. Okay, so there you go. No way, another wrong answer? Output was 1. Okay, so this is not right. So the minutes still do overlap. Okay, so I do need to keep track of that. Dang it. Okay. Here wrong answer. Again, oops. Okay. Yeah, I forgot to take into consideration that the minutes for the first time can be greater than the minutes for the second time. So we do need to take into account the use case when we need to borrow an hour. Right, okay, so If M3 is less than 0, then M3 equals 60 plus M3. Or here, plus equals 60. Plus equals 60. H3 minus minus. Okay, so this should be 7 instead of 1 because we need to borrow that hour. Then count up to minutes. Okay. Yay. Yeah, better late than never, I suppose. So that's cool. And I'm wondering, should we clean this up a little bit? Each one. I don't know, it looks okay. It looks decent enough. Okay, well, this is an okay solution. We'll just go with it and write it real quick in the other languages and then move on. I spent a lot of time on this one. I prefer to spend less time next time. Come on, it's going slow. Okay, let's post this real quick. A few solutions. Kotlin. We want to greedily consume the largest amount of minutes can take at a time. To convert the input string s to the target input source string. Looks good. Doesn't have to be perfect. JavaScript. Python 3. Rust. C++. Okay, let's get on to this. It's been a lot more time than I wanted to, so let's try to jam. T f equals s let hour equal instant slice 0 until 2 non-inclusive as a number. Minutes is the number of instant slice 0, 1, 2, 3 to 4 non-inclusive, right? We do actually 3, 4, 5 non-inclusive, right? There we go. All right, let's just do this. This thing here. And oops, hold on. Actually, I want to return a pair. This guy followed by that guy. Actually, let's do this. This guy. That guy. That map number. Console log f sub s. See what happens here. Just print it out real quick. I think it's cool, right? Yeah, it's cool. Okay. Let h1 m1 equal f sub s. h2 m2 equals f sub t. Let h3 m3 equals h2 minus h1, m2 minus m1. If m3 is less than 0, then m3 plus equals 60, borrow an hour. And then our count to 0, return the count in the end, while M3, if you can take 15, we'll take it. 3 minus equals 15. For that, oops, let's do, whatever, it's fine. Else if 5 is less than or equal to M3 minus equals 5. Else if 1 is less than M3 minus equals 1. Count for each of those. Okay, that looks good. That's not right though. The first one's coming up as 1, or it should be 3. To increment the hours, right? That count equals H3. Okay, looks good. Okay, cool. Good. Bam. Okay, Python 3, ST, F, S. So, yeah, we can just convert it as well here, right? Using a lambda. F equals lambda S. We'll return a pair. S dot slice from 0 to 2 non-inclusive as an integer. And S from 3 to 5 non-inclusive as an integer. Map int this guy. Make sure it's cool. F sub S. Map object. No, that's not what I want. A list of those guys. That's what I want. Yep. Okay. So turn the count at the end, and then H1 M1 equals F sub S. H2 M2 equals F sub T. H3 M3 equals H2 minus H1. M2 minus M1. If M3 is negative, M3 plus equals 60, and we'll borrow an hour. While, let's see, count equals H3, while M3. If M3 exceeds 15, we'll take that first. 3 minus equals 15. LF 5, take the 5. LF 1, M3 minus equals 1. Count is incremented by 1 each time. Ready. That looks good. 31, 32, 7. That's good. That's good. Bam. Okay, rest. ST. Define F as the string. And we're going to return. How do you express a pair? I don't know how to express a pair. To express pair in Rust. Tuples? Oh, okay, yeah, there's a tuple. I think that works. Okay. Tuple. What's the tuple return type? Just tuple return type. Rest. Okay. All right, I want to return an int, oops, I32. Okay, so let mute h1, mute h2 equal f sub s, borrow string, let mute h2, mute h3 equal f sub borrow t, let mute h3, oops, 1 and 2, m3 equals h2 minus h1, m2 minus m1. If m3 is negative, m3 plus equals 60, and h3 minus equals 1. Let mutable count equals h3, return the count in the end, while m3 is larger than 0 if m3 exceeds 15 or equals it. We'll take that, count equals 1 each time we do this. m3 minus equals 15. Else if 5, let's do m3. m3 minus equals 5. Else if 1, 3, m3 minus equals 1. Let's do else. Cool. Okay. Uh-oh. Expected tuple found. Oh, yeah, that's right. Okay. I'm not done with this part. Okay, so let's h equal s. Wonder if we can change this guy as a stir so we can take a slice of it. Stir. Let's do this shot rest. String to stir. We want to take a slice and basically convert it to an integer. The aster. It's not as stir. Zero to 2 non-inclusive. String to integer. From stir. Interesting. No, that doesn't work right. Parse to unwrap. Okay. Parse to unwrap. Y32 to unwrap. Let m equals, or let's just do this. Return h. H is a tuple for now. Okay, I need to figure out how this will compile. I want this to be a string still, I think. Okay, let's see what happens. Comparison operators cannot be changed. Did I miss something here? Colon. Filter expression cannot generic arguments. As soon as I take a value of method parse on stir, method not a field. To string. Mr. int. Interesting. This looks kind of like a nice way of doing it. Fromster. Parser fromster. Okay, so I32 fromster s.as stir subslice 0 to 2 non-inclusive. Oh, to unwrap, right? To unwrap. Nope. Fromster not found in Concon Fromster. Okay, well, that doesn't work. Might be an older version of older version of Rust, maybe. Mm-hmm. Okay, so I think we want it this way. Let's see. Let's see if I can just take a slice of it like this. S slice parse and wrap. That'd be cool. Can I have generic arguments? Method, not a field. Not a field is a method, then we want to invoke the method, right? Okay, that looks right. Okay, cool. So that's hours. This is minutes. Minutes. Oops. Minutes to be from 3 to 5, non-inclusive. Hours, minutes. Okay, should be good. 31, 32, 7 looks right. Okay, and finally C++. Okay, so let's wrap this up real quick. Yes. It's taking a long time. Auto F equals this guy. Taking the string as a reference. All right, auto H equals, let's do this. Take it by copy S sub 012 white space string stream S. Okay, do int hours equals 0, minutes equals 0. Just do auto. Return make pair hour minutes. Destructure already. Input H M. Auto sky. Or actually, we don't need that, right? We do need to do this though. Hours and minutes, comma separate, or white space limited. Okay, so auto H1, M1, S, auto H2, M2, T, auto H3, M3 equals make pair H2 minus H1, M2 minus M1. If M3 is negative, M3 plus equals 60, so borrow an hour, while M3 auto count equals H3, turn the count to the end. Okay, so if take 15, we'll take it. If 5, we'll take 5. And 3 minus equals 5. Well, it's fine. We'll just let it line up. Count each time. Okay, that looks good. That's good. Okay, that's cool. Alrighty, that took a lot longer than I was hoping, but whatever. Yeah, it's a decent solution, right? It's okay. Okay, so we have 44 minutes. Okay, half the contest left at least. Okay. Oops, Q1 took me half the contest. Well, whatever. 44 minutes left. Okay, we're given integer matches, winner and a loser. Okay, I'm gonna go grab some more coffee. I'll be right back. Okie dokie. Find players with 0 or 1 losses. In the case the player winner I is defeated by a player loser I in a match. From the list of answer size 2, the list of all players that have not lost any matches, and the ones that have lost at least 1. Okay, so it's a set of what exists here and not there, right? One exists on the left, but it does not exist on the right, right? Three, all the players that lost 1 match. Where's 3? You know, there's 3 not exactly 1. Okay. Okay, these are the guys that never exist on the right, and then these are the guys that exist on the right once. Right, okay. First is all values which exist on the left, oops, which do not exist on the right. Second is all values on the right, oops, right, which exist once. Okay, so what was that? 852. That's our game plan, and then it'll be the implementation. Implementation. Okay, so do this. Let var AB equals mutable set of integers. Return list of A.2 list, B.2 list. Okay, so then A will be all the ones on the left that don't exist on the right. So all that exist on the left that don't exist is you. Actually, I suppose we can use a counter, like a map for the other one that we can filter upon. Winner equals A dot filter. It's the first dot to set user. Okay. A is all the winners that aren't losers, right? Winner minus loser. Each of those. M equals mutable map of integers. This will be our counter basically. For underscore the second one in A. M sub X equals 1 plus M sub X of this operator 0. There's A, and then B would be this far. B is equal to M dot filter X count equals 1 dot map X count X dot to list. To list of A and B. Okay, something like that. Let's see what happens. Uh-oh, filter cannot be applied to filter. Oh, map it. Right, I don't want to filter it. Map it to the first, map to the second. And what is this? 1, 2, 10, 4, 5, 7, 8. 1, 2, 10. Does it need to be sorted? The values in the two lists should be returned in increasing order. Okay, so yes. Sorted. Does that work? Dot sorted. Okay, that looks good. 1, 2, 5, 6, and an empty. Okay, that looks good. Yay, okay. Thank you, Coffee. You helped me out. Got that done in about 5 minutes or so, so that's cool. Yeah, 5 minutes is quite a bit faster than the first question. It took me like half the contest, like 45 minutes. Okay, 8:57 a.m. Let's eat. All right, so it's about 5 minutes for the implementation. So what if we do this list of that dot map it dot to list dot sorted, and then just get rid of this stuff. All right, A is the winner minus the loser, and then B is this guy. All right, that's cool. Yay, okay, good enough. Let's jam on this real quick in the other languages and then move on to Q3. Hopefully I can get Q3 done. All right, a few solutions. Kotlin. All right, so the first okay, the answer is a pair of first, second. All right, so first is all winners which are not losers. Second is all losers which have lost exactly once. Looks good. JavaScript, Python 3, Rust, C++. Okay. All right, winners equals a.map. First, oops, there we go. X, new set of this thing. Loser, winner, loser. New set a.map. Second. Okay, let A equal winner minus loser. I wonder if this works. I don't know if that's worked this way in JavaScript or not. Let's see. Not a number. I didn't think so. Okay. Be all winners. Not X or not loser that has X. Right, that should work. Just filter it out. Dot map. Oh, dot filter, right? Filter. Looks good. Turn A B dot map. We just want to sort it basically. Each of those things, right? I want to take sort it. New map. Or let's each second of a m dot set x 1 plus m dot get x or 0. Okay, let b equal the map, and we'll filter count. Count equals 1. Map it. Get rid of the count, basically. X dot to set, right? Is it already a set? Yes, it's already a set. Okay, let's sort it. That was good. Okay. Looks good. Looks good. Bam. Okay, Python 3. Okay. Okay, and we're just going to start at 9:03 a.m. Here we go. Winner equals A. Let's see. 0 for it in A. User equals it's 1 for it in A. Okay, so A equals winner minus loser. Turn A, B. And we want to sort each of those. Sorted A, right? Sorted B. That works. M equals counter of the loser. B equals M dot items for X count, and if count is equal to 1, we'll filter that. X, and it'll be a set. Right, it's already a set because it's a part of the counter. Okay, that looks right. Let's see, have we got, oh, winner minus loser. Oh, it needs to be a set, right? Set of this guy, set of that guy. Looks, uh-oh, that does not look good. Too many over here. X for X count in M dot items, counter the loser. It's, yeah, okay, so it can't be a counter of the loser. It has to be counter of this list. It's 1 for it in A. Okay, that looks good. 9:03 to 9:06. About 3 minutes. It's cool. It's cool. Bam. Okay, rest and then C++. Yeah, I goes back I32. Type VPI goes back VPI. Okay, here's our two-dimensional array, VPI. VPI, okay. So let mutable winner equals use std collections hash set a dot map it's sub 0 a dot iter dot map dot collect loser hold on. Loser one hash set from that, I think, right? Hash set. Hash set. Return an empty vector for now. Oops, let's see. So I just want to print this thing out real quick. Println debug thingy. Oops, debug thingy. Inner loser. Okay. Expect at least one generic argument. Okay, hash set of I32. Hash set of I32. Okay. Maybe it compiles okay. Okay, that looks right. Cool. Okay, so those are my hash sets. And then let's the hash set of I32. Everything in winner that's not in loser. Let's see, what's rest set difference? Difference. Difference. A dot difference. B dot collect. Winner dot difference. Loser collect. Print A and see what happens here. Println, oops, macro. Okay, I need to borrow it. Collect I32s. Okay, and then borrow the loser. From iterator. Uh-oh. Expected struct hash set found I32. Maybe collect is okay like that. Oh, compile error. Cannot be built from an iterator over elements of type borrowed I32 iterator. Winner difference dot iter dot collect. No method name iter for hash set difference. Private field, not a method. What? Set underscore. Set from. No, I want this minus that. Winner dot difference. Collect. This sure is taking a while. Okay, good. Alrighty, that's that. Collect. Actually, I want this guy to be a vec of I32, isn't it? Set to a vector. I wonder if this works. Vector. So I want to sort this vector. Set difference to collect. First hash set to vector. Hash set to vector. Into iter.collect. Interesting. Just into a vector like this. Looks good. .collect. Sorted. Type annotations. Collect. This dot sorted. Collect I32 sorted. Item ampersand I32's borrowed. Into iter to collect instead of borrowing it. Clone or into iter. Built from this guy. Clone, collect, sorted. No. It cannot be built from this guy. Into iter hs. Into iter. I have to specify it explicitly. It doesn't know what it is. Okay, I'm going to do this later. I really want to get down to the third or fourth question here before the contest ends. I think I only have like 15 minutes left. All right, let's just pump this out here real quick in C++, and I'll come back to Rust. Okay, okay. Let's do this. Using set equals unordered set of integers, set winner, set loser for auto each pair of the input array A. Winner and loser equals tie pair sub 0, pair sub 1. Okay, winner, insert X, map, unordered map. This will be our counter. Map M. Okay, so M sub Y plus plus. Loser to insert Y. Okay, and then yeah. Set A is this. Ordered. Ordered is fine. set difference winner dot begin winner dot end loser dot begin loser dot end back. Oh no, inserter. A dot end. There's the set difference for A. A is can be returned as a vector. Those guys are its turn. Vi sub A dot begin, A dot end, B dot begin, B dot end. Copy if M dot begin, M dot end. Set A, set B. And pair X and the count of X tie pair sub 0, pair sub 1. If, let's say return. So those would be our pairs. Actually, this is easier. Just do this. For auto X count in our map. If count is equal to 1, then we'll do B dot insert X. Looks good. Looks good. Okay, and that's good enough for Q3. I'll come back and do the rest later. To do implement me stick C++ there. Cool. Alrighty. And we have about 10 minutes left for Q3, I think, right? Yeah. Okay. Q3, we have about 11 minutes left in the contest. Okay, let's jam on this one. Here we go. Maximum candies allocated to K children. Okay, we can subdivide them, but can't merge them. Return the maximum number of candies each child can get. We can divide candies of 1 into 2 piles of size 5 and 3. Candies 2 into piles of 5 and 1. Now we have 5 piles of candies, sizes 5. We allocate 3 piles of size 5 to 3 children, proving that each child cannot receive more than 5 candies. There are 11 children, but only 11 candies in total, so it's impossible to ensure that each child receives at least 1 candy. Thus, the child gets no candy, and the answer is 0. Okay, so we can divide them, but we can't merge them. Key children each gets the same number of candies. So if the sum of the candies is less than k, then it's 0, right? If sum a is less than k, return 0. Okay. A and k, our t equals a dot sum. If total exceeds k, or no, it's less than k, right? T is less than k. Turn 0. Otherwise, we'll split up the array of candies into the minimum size chunk. Return the maximum number of candies each child can get. Right. The maximum is 5. What if there's 4 kids though? It's 9:20, about 9:20 a.m. Game plan. Corner case when we don't have enough candies to give each child at least 1 candy. Okay, and then the question was, what if we have more than 3? K equals 3, right? Let's say, all right, let's say k equals 4. Then what does that imply? A equals 5, 8, 6, and then k equals 4. So what's the biggest chunk we can make 4 piles of? We have to reduce these guys. So we can do 5 can turn into 1 and 4. 8 can turn into 4 and 4. And then 6 can turn into 2 and 4. So we do have 4 4s. So that means that with 4 4s, we return 4, right? Okay, so what if we have 5, right? Let's try that next. All right, we have 5, then what do we have to do? We have to take it into smaller chunks. So how is it that I guessed 4 in this first place? All right, the total is 13, 19, right? 19. And then 19 divided by 4 comes out to be 4 point something, right? 0.75 or something. 19 divided by 4, 4.75. Okay, so maybe start there as the best guess. Best guess starting point can be sum of A divided by K parts. Like that's kind of our best case. And scoot down from there. Okay, so candy's length, K is huge. K is gigantic. Is that a trillion? 12 zeros. Yeah. Billions, 9 zeros, trillions, 12 zeros. Right, so note, K is gigantic. 1e12 is 1 trillion. So, I mean, that's definitely something to take into consideration to avoid TLE, most certainly. How much time we have left? We have 4 minutes. Okay, something tells me we're gonna probably come back to this. I'm not gonna solve it here in 4 minutes. But we can probably still come up with a game plan at least. Okay, so to avoid TLE, I think we need a sublinear amount of guesses. Each guess at the cost of a linear scan for validation, right? So that'd be O of n times log n algorithm. And that would imply we need to use binary search to constrain our guesses in a logical way, which continually divides the search space of candidates in half per operation. Hold on, I'm getting a call. What? Yep. Okay, so I think I can do binary search here. How many times I got? 2 minutes, 43 seconds. Binary search per guess, right? So if we're gonna guess, it's our best guess is sum divided by k, right? It's the minimum value, minimum of that. Right, at the very minimum, each of them can get one candy. Okay, let's write it. Function f, our binary search, integers from I inclusive to j inclusive, and then how many candies you want will be that returns. So at the very minimum, it's 1. At the very maximum, it's the floor of k divided by a, or the minimum of, right? Okay. Minimum number of candies is 1. Maximum number of candies is the minimum of sum of a divided by k, like the floor of this, floor of that, and or yeah, the minimum value of a dot min. Low is 1, high is math max or min, math floor, or actually, yeah, it'll do the floor already for me, right? A dot min, return f sub low high. So that's our low sum, and our high is 1. Okay, so while I is less than j, turn I var k equals I plus j divided by 2. Does this look right? Hold on. the minimum candies that work for everyone. You can divide it, but you cannot make it bigger. How many candies can we take for each? And is it sufficient for each of the K children? Right? Need to pre-compute the count, the quantity of children. Right, okay. The maximum that each of them can get. All right, so it's at least K. Okay, so we're going to say we're going to take of size K, right? Take. And then how many do we have then? Take is this. Have for X and A. Have plus equals X divided by take. That's how many we can take from each pile in whole increments. That's how many we have. If have is, we want to maximize take. We want to maximize take as long as we have enough. Okay, so if have is less than K, it's not enough. Like we need to take more. I equals I plus 1. Otherwise, if we have enough, then we want to try to make have is insufficient. Here's have is insufficient, so I need to take more, like move that. Otherwise, have is sufficient. We can take potentially less, right? J equals I, or J equals K, right? K plus 1. Take plus 1. Take. That works. Something like that. Cannot be reassigned. I underscore J underscore var I J equal the mutable versions of I and J. I'm pretty sure the time's up, so I'll probably finish this up, debug it. I'm pretty sure I'm on the right track. It needs to be a pair. Let's see. Yeah, the contest is over, so we got 2. That's cool. Min. Whatever. We'll just try to finish this up here in a minute or 2. Some driver type meets mismatch. There's a whole bunch of them. The sum is huge. I is a long. A dot map. It dot too long. A dot map. It dot too long. Minimum all those. Long. Wait, no. Oh, okay, whatever. Divided by K. Okay, yeah, so there is some trickery here. For type is long, but int was expected. Yeah, let's just do this. Try to make life easier on myself. Long. It returns an int in the end, not to int. Turn half into a long. Int, but long is expected. Man, again, a whole bunch of compilers. Unresolved reference, receiver type mismatch. Oh, needs to be dot sum. Sum. Should be 5. Okay, so that's not right. Answer is 1 and expected 5. Okay. So here we go. To do upsolve. Yeah, thanks for watching. Cheers. Now let's move on. We're all done for the day. Yep, catch you next time.